Heterocycles containing phosphorus and arsenic compounds. So let's begin with that. In this synthesis of 5-membered heterocycles with the phosphorus and arsenic compounds you have to study. So let's begin with the phosphorus synthesis. So this phosphorus is having 3 types, that is, one is your phospholene, phosphols and phospholene. Okay, so this phospholene is nothing but it is an alkane compound. Phosphols is like furans, right? If you will remove one of the if you will add the phosphorus group instead of the oxygen group, okay, that is similar to the furan, and that is your phosphols also. And then phospholene, that is your ene compound. Okay, so moving on to preparation, and like we are preparing the different types of phosphorus compounds. It can be either the phospholane, phosphols or phospholene compounds. And so what we are doing is, in the first preparation, so here is the sentence which I have given over here. The cyclic phosphine oxides, that is, this cyclic phosphine in oxides will be prepared on treatment with the dienes, okay, conjugated dienes, and the chlorophosphines. Okay, so that is you're taking the any of the halide phosphines when you are treating this with the conjugated dienes, it undergoes the cycloaddition. Okay, once it undergoes the cycloaddition reaction, and then you will get back this adduct, and then upon hydrolysis, as you are replacing, the 2 halides groups are getting removed, that is getting cleaved out, resulting you in the cyclic phosphine oxides. Okay, then moving on to second preparation, that is the 1-hydroxy phospholane 1-oxide, that is this compound, and this will be obtained in by the reaction between the phosphine and the 1,4-diketones. You know that one, how you have to number it, 1, 2, 3, 4. Okay, diketones compound, when it is treated it with the phosphines upon acidification, and you will result in the first structure, the phosphones will be formed, and then again upon treatment with the hydrogen peroxide, it's the 1-hydroxy phospholane 1-oxide, 1-hydroxy, okay, phospholane in phospholane 1-oxides. Okay, that is your oxygen atom is attached over here. So it is this is the structure. Moving on to next slide. Here, from conjugated dienes, how we will synthesize the phosphonic acids. We are taking the conjugated dienes and then we are treating it with the phosphodioxyls. Okay, when we will treat it with the halide group, this X group can vary from the chloride, bromide and all. If it is chloride, it is chlorophosphordioxyls. Okay, so halophosphodioxyls, in general you can say this structure it has, as it undergoes the cycloaddition reaction, and then once it undergoes the cycloaddition reaction, then what happens is when this lone pair of electron goes attacks over here, this bond shifts, and then this bond makes one bond with the phosphorus, and the halide group will come out. Okay, X minus will be there over there. That X minus will go attack to the carbon atom. Meanwhile, this bond between the oxygen and the carbon, that is your CO bond, breaks. One of the bond will shift towards this side. Okay, resulting you in the esters of your cyclic phosphonic acids. Alright, then moving on to next preparation, that is you are taking the butadienes. When the butadiene undergoes the treatment with the phenyl phosphines and then alcohols in presence of your benzene, okay, or pyridine structure. Okay, so in presence of the pyridine or the phosphines, benzene, phenyllithiums, lithiates will tell at room temperature. If we are adding all these reagents, then the phosphols will be obtained. Okay, And then moving on to next reaction, that is when 1,4-diphenyl butadiene will be heated with the phenyl phosphonous dichloride at 221 to 230 degrees Celsius, it will give you 1,2,5 triphenyl phosphols. That I'll show you in the next slide. Okay, so here comes that reaction, and you are taking the 1,4-diphenyl 1,4 1 2 3 4. Okay, 1,4 phenyl diphenyls butadiene structures upon heating and upon treatment with the phosphine chlorides, it's at 214 degree to 230 degrees Celsius. Then first an adduct formation will be there, that is your phenyl phosphorus dichloride. And okay, again upon treatment with the base, one of the HCl molecules gets cleaved out. When you are treating it with the base, then the HCl molecules will get cleaved out, resulting you in the, see here one bond will be there, right? So here what happens is the HCl molecule gets cleaved out, resulting you in the 1,2,5 triphenyl phosphols. Okay, and then moving on to next, that is your 6-membered phosphorus heterocycles. Is till here you have studied the 5-membered heterocycles, phosphorus heterocycle. Now moving on to 6-membered, here also there are two compounds, that is one is your phosphorinane, one more is phosphorin. Okay, phosphorin can be prepared by in only one step. So what happens here is, we are taking the 1,4-dihydro 1,1 dibutyl stannabenzene. First we have to take the tin compounds and then dibutyl tin compounds. Upon treatment with the phosphorus tribromide or DBU. DBU is nothing but it is 1,5-diazine bicyclo 540, and okay, DBU is nothing but dibutyl stannabenzene. Okay, so in presence of the DBU, the phosphorin will be appeared. Okay, then moving on to next slide. Here mechanisms are not required, that's why I have not given you the mechanisms. Okay, they'll ask just for the predict the product. Then again we are taking that stannadibutyl compound with the two substituents attached. Okay, two bulkier groups we are attacking it, and upon treatment with the phosphorus tribromide or phosphine, then again the phosphorin is obtained. All right, from the Grignard reagent, how we are generating the phosphorinane is we are taking the 1 2 3 4 5. Okay, 1,5-dibromopentane. When we are taking that 1,5-dibromopentane upon treatment with the RMGX, what happens here is this MgBr. Okay, we are treating it with the MgBr. Okay, okay, magnesium. If we will treat it with the magnesium, what happens here? First there is a generation of carbanion. Once the carbanion is formed over here, or again you will get back this structure. All right, and upon treatment with the phosphorus chlorides, phosphine chlorides in the presence of the base, then the phosphorinane is obtained. All right, then moving on to next reaction, that is your 1,5-dibromopentane. When it is treated it with the tetraphenyl diphosphine. Okay, this is your tetraphenyl diphosphine compound. And in the first structure, what happens? The phosphorus, which is having a lone pair of electron, will go attack to the carbon atom. Okay, that is your methylene compound. Once it will go and attack to the methylene compound, then the bromine, which is acting as a good leaving group, will cleave out then, and you will get back this phosphorinium salts, quaternary salt. Okay, after the formation of your quaternary phosphonium salts, then again the next, whatever the bromine which is cleaved out, that bromide will go attack to the phosphorus atom. there is a neutralization of the positive charge from the bond and of the phosphorus. Two of the phosphorus linked together, right? This bond will neutralize the positive charge, resulting you in this structure. All right, and once this structure is formed, there is a cyclization, ring cyclization, which is taking place. The phosphorus, which is having a lone pair of electron, will go make one bond with the carbon. Meanwhile, there is a cleavage of your bromide, okay, resulting you in this structure. Okay, and then again upon treatment with the NaOH, after the cyclization takes place with this ring formation, and upon treatment with the NaOH, you will result in 1-oxo 1-phenyl phosphorinane compound. Okay, moving on to next slide. Here again the different substituents we are attacking. So here we are taking the ketone compound, diene with one of the ketone compound, diphenyl ketones. Okay, so here if we are treating it with the again the phosphines, you will get the phosphorinane. All right, then moving on to next reaction, that is from phosphol to phosphorine. Okay, this is phosphorin is nothing but where there is the benzene rings, there is a delocalization which is taking place. Phosphorinane is your like an alkane system, there is no delocalization inside the ring. Okay, and then if we are taking the phosphol, if we are treating it with the diphenyl compounds, okay, at 230 degrees Celsius, 7 days is, if we will keep it for 7 days at 230 degrees Celsius, then only phosphorine will be obtained. Moving on to next, that is your arsenic compounds. Here comes the arsenic, heterocycles containing arsenic as heteroatom. Okay, then here also there are three possibilities, that is your first one is your arsolane, arsol and arsenine. All right, then moving on to next slide, we'll see the synthesis part. Once what happens here is there is a cyclization, that is the rearrangement reaction which is taking place over here. Then after rearrangement reaction, then comes your arsenine compound. Moving on to next reaction, this is your first one of the preparation step, and then not this step, it is the one of the complete reaction. Okay, moving on to next, it is your again you are taking with the different substituents attached. Here you are taking the R as your compound, that is your alkyl substituent, but here in place of R you are adding the proton and OAC. Okay, again upon treatment with the AsCl3, that is your arsenic trichloride, and in the first step the arsenic chloride will be obtained. There are two possibilities. One is the wedge bond which is present in the front, there will be the hydrogen, and the next one will be your, or in the back there will be the hydrogen atom. All right, then again if you will treat it with the one molecule of HCl gets cleaved out either from here or from here. Okay, it depends on which is the major product. So once it the HCl gets cleaved out deacidification, and then you will result in this compound. Okay, acetyl arsenine compounds, acetylated arsenine and compound. Upon treatment with NaOH or methanol, then the AC group will go or upon treatment with the base or an alcohol, or then the H will be obtained, alcohol OH. Okay, and then this can again be resonate, this bond shifts over here, then this bond shifts, and there is a cleavage of the hydrogen atom, resulting you in this structure. Then comes your ring expansion reaction, wherein you are taking the lithium arsenide compound, lithium arsenides with the phenyl substituted at lithium arsenides compound. And when this is treated with this reagent, and that is your phenyl dichloro sodium carboxylate. When it is treated with this, then the lithium, one of the lithium with the chloride atom will cleave out as the LiCl. Okay, lithium chloride will cleaved out, and then you'll get back this structure. Once you'll get back this structure upon heating, then the NaCl will go, and the carbon dioxide with the evolution of the carbon dioxide, you will generate the carbene structure. Once the carbene structure is formed, then this carbene will go and make a bond with the carbon atom which is attached with the phenyl. Okay, and then there is like the resonance which is present over here, and there is a generation of the carbanion. Okay, once the carbanion is generated, this carbanion moves back, and then there is the ring opening which is taking place over here. Okay, after the ring opening reaction, you will get back your arsenine compounds. Moving on to the fourth preparation, and that is your acrylonitrile adduct. This is your acrylonitrile adduct of the phenyl arsine, and this upon treatment, here what happens here is there is a hydride transfer. This hydrogen will transfer to the carbon, and one of the bond will go. Oh, and there is a ring cyclization which is taking place over here. Once you are doing the ring cyclization, there is a formation of ring, right? And then you know that you have studied the conversion of the nitriles to the amines, that is your C triple bond N to NH. Okay, so here the hydrogen will this one bond will shift over here. This bond will shift, it will give you the negative charge N minus. This will again abstract the proton, resulting you in the NH2 over here. Okay, and then one of the bond will be present, resulting you in the 4 amino 1 to 5 6 tetrahydro 1 phenol 1 phenyl arsenine 3 carbonitrile. So please, whenever they will ask you, the majority of the questions will come from the synthesis part. They can either ask you to write any of the synthesis of the phosphorus containing groups or the arsenic containing heterocycles. Either it can be 5-membered or 6-membered. Accordingly, you have to answer. Moving on to arsole synthesis. Here you are taking the buta-1,3-diene compounds upon treatment with the phenyl arsenine, and in the presence of the solvents such as your benzene or butyl lithium, then arsoles are obtained. And again here, if we are taking the tetraphenyl butadiene dilithiazoles, also again upon treatment with the alkyl arsino or dibromides, then the tetraphenyl derivatives will be obtained. Tetraphenyl arsenal derivatives will be obtained. Okay, arsoles derivatives will be obtained. And again, if we are taking the pentadiene 3-one upon treatment with the phenyl arsenine, and then 1 phenyl 2 arsolene 4-one will be obtained. Here there is no need of writing the mechanism, that's why I have not shown any of the mechanisms over here. Thank you. If you have any doubts, you can ask me in the comment box.